giving like them smart.
Okay, we got a situation here where this is the kind of problem we can represent with the linear system, right? So principal at a middle school buys 23 graphing calculators and 26 tablets for $56.14, right? Okay, is it? Probably. It seems like it's kind of expensive.
I've never been in a situation where I needed to buy that many, so I don't know.
Yeah, it seems like a lot of money, doesn't it?
That's actually a good price.
I don't know. That may be all right.
I think that'd be
Pretty good, maybe, actually. Okay, so
Actually, that's a bargain.
that
seems
is-
like a bargain. All those tablets, yeah, it seems
No,
pretty
the
good.
graphing calculators.
Yeah, they're like 70, 80.
Yeah.
So he actually
Okay,
definitely.
second order is made where we get 39 graphing calculators and 22 tablets for $61.18. Okay? Now, what we're trying to figure out here from that information is, what was the cost of each calculator and what was the cost of each tablet? Okay? We can do that. Now, let's be systematic about this. When we're trying to solve an application of math like this, the first thing you always want to do is go to what's being asked. All right, what are we trying to find? Cost of each calculator and cost of each tablet. That's not given to us directly, right? So those are the unknowns. Okay, so let's assign variables to those.
X
Make
and
sense?
Y.
X and Y.
Yeah.
So let's let X equal calculator cost. And let's let Y equal tablet cost. Okay? How many unknowns do we have? Two. So how many equations do we need in our system then? At least two, right? At least two. So somehow we got to come up with at least two equations. Well, let's look where we've got some information about calculators and tablets. Well, here's this first paragraph. The principal bought 23 graphing calculators and 26 tablets for $56.14. Okay, can we turn that into an equation?
Yes.
Yeah.
What do you think? Yes, sir. Help us out.
23x
Ah,
plus
okay.
26y equals 5614.
Okay. Okay, you're correct. Let's talk about why this works. Okay, the total cost, really this is just the cost of the calculators, isn't it? 23 calculators times the price of X per calculator tells us the total amount we paid for calculators, right? And 26 times Y dollars per tablet tells us the total amount spent on tablets. And the combination of the two, the sum of the two, is $56.14, right? Okay, well, we can do something similar down here. Now that the cat's out of the bag, the second equation is pretty easy, right? We know that another order is placed, 39 graphing calculators and 22 tablets for $61.18, right? So we can come up, everybody agree that's no big deal. We can come up with a similar equation. 39x plus 22y equals 61.18, right? So yeah, we can just use elimination, or let's just assume in this case, being as we're rounding this anyway, we're rounding to the nearest cent. We're gonna just use technology, right? Assume we have technology available. I mean, really, on your phone, you've got Desmos, right? You can. You get that, right? So you can always use Desmos on your phone. All you got to do is just cross those two equations. So in Desmos, I would just do that, right? I'm just going to enter the red equation. Don't need to do anything fancy. I just type it in exactly like that. I don't have to solve for y like you do on a graphing calculator. In Desmos, we just type in the equation. Type in the equation for the blue line, and I look for the intersection. So what's that tell us?
One of them is $70 for the X.
Which one's $70?
Yeah.
Yeah, the X. So that was the graphing calculators, right? So we know that the cost of graphing calculator is $70. And we know that the cost of a tablet is $154, right? Got it. Okay, let's look at one that's slightly different. One more of these. And then we'll do all of them. You guys can think of it. So this time, Kirk's designing a garden for his backyard. He's got 24 feet of fencing available. He wants to be rectangular. But he knows that for aesthetic reasons, he really thinks it looks best if the width of the garden is two times the width.
And he is capped.
He is, that's right, that's right. So if we want to make a picture, we could represent this with a picture if we wanted to, right? Here's the garden. call that x and call that y. X is the width, y is the length, let's say, right? So. So I need to come up, I've got two unknowns here. I gotta know the width and the length. So I need to have two equations. What's one relationship up here that I could exploit that's gonna help me relate x and y? 24 feet of fencing. The perimeter of the garden is gonna be 24 feet. So how do I turn that into an equation then?
X plus y plus 24.
Is that right?
Or 2x plus 2y.
2x plus 2y equals 24, right? I need both of the sides that represent the width and both of the sides that represent the length, right? So 2x plus 2y equals 24. Okay, good. That's not enough, though. I have two unknowns, so I need another equation. There are a lot of different ways I could make that work, right? Infinite number of values of x and y if I want to use decimals and, and square roots and all that. There's an infinite number of different choices of x and y that would still fulfill that equation, satisfy that equation, right? But I've got to find the one that's going to do all the stuff that he wants. And the other condition he had was what?
2 times.
Okay. He wants the width of the garden to be 2 times the length, right? Now let's restate that one. We could summarize, I think this helps sometimes when you're doing word problems, is to take the English and kind of just dumb it down to where it doesn't have to be so grammatical, but we're still going to use words. Couldn't I summarize that by just saying width is twice length? You get that? Okay. So we can take all that stuff up there in blue. So width is twice length. That's easier to turn into a mathematical sentence, meaning an equation, right? What does the word is typically represent in an equation? Equals, yeah. So there's going to be my equals sign, right? And that just looks like width. Well, width was x, right? So x equals, how do I say twice length? 2y. Good. So x equals 2y. It's an easy system to solve. We could just use substitution, right? In fact, it's so easy, let's just do that. If I plug this x in right there, I'm going to get 2 times 2y plus 2y equals 24. So what is that? 4y plus 2y is 6y equals 24, so y equals 4. Okay, then I got to find x. All I got to do is go back up, and there's my equation I can use for x, isn't it? There's my substitution equation. So if I plug in 4 for y, I get y equals 2 times 4 equals 8, right? So I got my answers. Oh, sorry. That's supposed to be an x, isn't it? If that's supposed to be written down wrong. X equals 2 times y, y was 4. So x is 8, and y is 4, right? And of course, I'd get the same thing if I graph those two lines. I get the point of intersection in 4. Right? Make sense?
It's funny how
Okay.
the
No big deal. What's that?
it's funny how the rectangle is X.
Well, it's,
I
but,
know it's not exactly.
yeah. Okay.